fine. No, we don't. We have Deputy Stanley still waiting. One person's waiting. There we go. All right. Oak Hill Classroom, can you put it on your video so I can see you guys for a minute?
We don't know who Oak Hill Classroom is.
All right, which one are you two assigned on to?
We're up in the study.
Ah, you're in Engine 7. Okay, you're up in the study. It says Engine 7. Now I get it. Okay. So you guys can see this okay?
Yeah, we can see you.
Okay.
Where the hell am I?
Muted. Okay, so let's see everybody here. All right, let's get started. So, I'm gonna share screen. You hit record, right? Okay. Okay, so what we're gonna do today is go over basic pump math. This is usually where everybody gets really confused. So I went through these and we're gonna go through the slides. There's some we're just gonna forget about. And then there's some we're gonna spend a little bit of time on, but I'm gonna give you guys some stuff that at the end of it, we're gonna kind of go through the slides, and then it's gonna be more important that there's gonna be some things that I go over at the end. So what you're trying to get to is when you're doing the math for this, is you're trying to determine what to set the gauges at, okay? Which is setting your pump discharge pressure. Now you have the classroom idea of this, the on paper idea of this, and you have actual fireground stuff. What I'm focusing on with this is we're going to focus on the fireground stuff to be able to, for you guys to be able to get to the proper pressure that you're supposed to be pumping the trucks at. Hydraulic calculations, what you see down here at the bottom is all the ways that you can come up with that right number to be able to set for your pump pressure. Now, you're going to hear me, I'm going to probably bounce around a lot because over the years, every iteration of a classroom that comes out, it used to be engine pressure, it used to be pump pressure, it used to be discharge pressure. So you're going to hear me bounce around a lot. Just know that it's all the same thing. What you're trying to do is generate pressure at the pump to overcome friction loss so you can make water come out at the right gallons per minute at the end at the nozzle.
Hey, Jeff.
Go ahead.
We supposed to be seeing something like sharing the screen?
Yeah.
Because we're not, or at least I'm not.
Well, you got to hit join video.
Really?
Yep.
Where the hell is that?
Link. You're set, Jared. Hold on one second. Go to Zoom.
Mm-hmm.
Go to share screen.
I did.
You want to share the
Can you see it now?
Yes, much better.
Okay. Engine 7 up there. You guys up in the study. Can you see that now?
Yeah, we can see it.
Yeah, you probably should have told me that earlier. That's Welch's fault.
We thought you meant your screen. We did see your screen.
Okay. Okay. So we're going to go from current slide. So all we did is just, we missed through the burn thing. All right, so here's the list of ways to figure out all that crap. You look down at the bottom, you got flow meters, calculators, pump charts, the dreaded Q forms. So, all right, flow meter. The flow meter is the truck telling you how many gallons per minute is coming out at the end. It doesn't help you generate what pressure to come up with, other than just looking at it and saying, okay, I want 185 gallons per minute, and you dial up the throttle and you look at the flow coming out of your flow coming out, going down the hose line, and that's what it is. Now, the problem is that's the flow coming out of the pump. It's not the flow coming out the end of the nozzle. When that impeller spins, it's at the discharge. The water going by it just spins faster and faster, and it generates how much water is coming out. You need to know how much pressure you're set at. I don't care what this says, displays the volume of water moving through a hose. There's no way to input into a flow meter unless you actually punch in, I'm flowing 1 3/4 inches. I'm flowing a 3-inch. I'm flowing water through a 5-inch. There's no way for that pump, unless you specifically dial into that flow meter and punch it in the right numbers for it to come up with the correct calculation. There's too many variables for that pump to know exactly what it's doing. So this slide is wrong. It'll tell you basically how much water is coming out. It'll tell you how much water is coming out of the discharge. It's not telling you what's coming out at the end of the hose line. So your flow meters are good on the water supply side or from the master stream side. If you're setting up a master stream for the ladder pipe, and you know that, okay, you want to throw the ladder pipe flows 1,000 gallons a minute, okay, you just set it up and you flow water through and you set it up. Yep, I know I'm do the calculations. I should be able to get to 1,000 gallons a minute. So it works good on that. It works good on the supply side. If you're doing relay pumping from the hydrant to the tack truck, it gets you a ballpark there. Don't rely on only flow meters. They're good for what they're good for, but they're not the end all be all. So these calculators right here is, if you guys looked, and I swapped it around, but I don't want to lose you again, so I'm not. This is what I'm holding in my hand right now. These are really pretty cool. They're really good for figuring out flows and stuff like this. Are they going to be something that you're going to use on the fire ground? Maybe, if you're really that far into it, you might. But there's a lot that they're very fine printed. It's kind of one of those things, it's nice to have. It's really good for working out the pre-flow on pre-plans and working out stuff ahead of time. Pump charts. Now this is something that works out very well on all the engines. It should be on all the engines. One of the things you should do today is, after the class, is go down and look at the pump charts on each pump panel and see if there's one there. On engine 6 and on ladder 1, there's pump charts, and it should be a colored sheet, says Fireground Hydraulics on it. And on each one, on pump panel, there should be a pump chart that's right on there. If you know how to use these and learn how to use them, all the information you need is right here. All you need to know is how much water you want to be flowing and how many lengths of hose you got out, and it'll tell you because what you'll need to set your pump pressure at. Because this, coming up with these pump charts, is exactly what you need to use for the slide rules and the calculators and everything else. Hydraulics calculations, we're talking about fireground stuff. You need to know how to do the fireground. There's 2 schools. There's 3, actually. There's the classroom, there's on paper doing pre-plans, and then there's actual fireground, doing it on the fireground, running the truck. So again, now they're calling it pump discharge pressure. This is what I'm always called engine pressure. Engine pressure equals nozzle pressure plus friction loss. And then it goes plus or minus elevation, plus any appliance you got on. same thing, okay? So nozzle pressure, that's the pressure you need to have to make the nozzle, like we've talked about before. That's the pressure that you need to have to make the nozzle operate and to give yourself a working stream and to give yourself the maximum flow for that. Friction loss, again, that's what the resistance of the hose against the water, what you have to overcome to generate the right pressure. Appliances, I mean, these talk about Siamese and Wise and water thieves, that sort of stuff. In today's firefighting, those were really a big thing back in the 50s and 60s. Occasionally today, we'll still use a Y, but we're really not using water thieves anymore, unless we're in the forestry world. We're not using, I really haven't seen a Siamese used for years. We do use master stream devices, and basically there's random numbers anywhere from 8 to 15 pounds for each time that you apply a master stream device or any type of these appliances. Rule of thumb that I've always used, add 10 pounds for the appliance. Kind of catches it right in the middle so that you're not under pumping it very much or you're not over pumping it very much. And then elevation. Elevation is obviously change in the height of where you are to where you want to put the water. Now, this can be floors in a building, or it can be a hill. So if your water supply is at the top of a hill and you're pumping down to the fire, you may not even have to be there. Or you're just going to run, or you're just going to have to run the truck at an idle. If it's the other way around and you're pumping the water up the hill, you have to take that into account. Rule of thumb, when you are pumping a fire and you're on the attack piece and you have hose lines off, you don't worry about floors until you're above and you're in a traditional 8-foot ceiling height. You don't worry about frictional adding for the elevation till you're at the 3rd floor. If you add third at the 3rd floor, you add 5 pounds for each floor that you're going up. We keep going over this. Pressures, nozzle pressure, hand lines. Okay. We went over this before. Smoothbore tips. Anything that you're going to hold in your hand is going to be 50 PSI. If you're using a hand line and it's got a fog nozzle, all fog nozzles, whether they're in your hand, on a portable device, or on the end of the aerial, all of them are going to be pumped at 100. Master streams, fog nozzle, like I said, 100 PSI. Smoothbore is at 80. So whoever laid out this slide from the state has this completely backwards. It's just remember, smoothbore 50, smoothbore master 80, everything else, if it's a fog nozzle, 100. You get rid of all that crap and just remember those 3 numbers. That's all you got to remember. All right, obviously friction loss, the resistance that you got to cut through and to overcome through the whole thing, through the whole water supply system. We already went through this. Moving the water against the side of the hose. Q formulas, we're going to go right past all this, because they're useless on the fire ground. The hand method. Now, I know out here, and I know it's in Scarborough, I know it's been in other places, there are all these ways that you can remember that you learn how to figure friction loss. You shouldn't have to learn a whole process just to get a number. That's dumb. So we're going to go right past this. The hand method, yeah, you're supposed to be wearing gloves. All right, drop 10 method. This is kind of okay. No, not doing that. Okay, so what we're sitting at right now is, I'm gonna give you guys some givens. So 1 3/4 hose, let's go back to looking at me because we're done with the slides, I believe. Yes.
Stop sharing and talk.
All right. And then we're just gonna look at this.
They'll see you.
Okay, so bring my screen down here. That's better. Okay, so I'm going to give you guys what I call givens. For 1 3/4, you use 50 pounds per 100 feet will give you 185 gallons a minute with the nozzles that are set up for Scarborough Fire Department. That is standard across the board. That's all you got to remember. 50 pounds per 100 feet. Okay, then you add in what you need for your nozzle. That gives you 185 gallons. That will give you the right pressure that you need to pump the line. 2.5 is 15 pounds per 100 feet at 250. That's what the standard, every 2.5 hose is supposed to pump 250 gallons a minute. So for every 100 feet, add 15 pounds per 100 for friction loss. 3-inch, figure 300 gallons a minute, do 20 pounds per 100 feet. 5-inch, now for 5-inch, if you're up into that realm, you don't really need to start figuring a lot for friction loss in 5-inch until you get up to the bigger numbers. At 500 gallons a minute, you only got to add 2 pounds per 100 feet for 5-inch. There's like no friction loss. There's none there. At 1,000 gallons a minute, you only got to add 8 pounds per 100 feet. It's not until you get up to 1,500 gallons a minute, which is the capacity of the pumpers that we have, that you got to start figuring in 20 pounds per 100 feet. So those are givens. Engine pressure. The next thing we want to talk about is you got to remember this, is the engine pressure that you're trying to generate on the pump panel is the nozzle pressure. Look at the type of nozzle that you have, and that's your first number you use. Friction loss. How many lengths of hose is out there? How many gallons per minute that I'm trying to do? How many appliances I got in there, and do I have to figure in elevation? So again, we talked over the nozzle pressures, 50 for a smooth bore hand line, 80 for a smooth bore master stream, and 100 for any fog nozzle. Okay, whether you're using it as a master stream or whether you're using it for a hand line. Now, one of the things that mess people up when you're trying to do friction loss and come up with all the right numbers is they start counting pieces of hose on the ground. So when they're counting, they look in the back of the hose bed and they see there's 5 lengths of 4-inch out there. You know, they're figuring, okay, I got 500 feet. When they start looking at the 2.5 and 1 3/4 that's laying around on the fire scene, they start counting pieces of a hose. They start adding up the hoses. Well, that's only 50 foot because all attack hose from 3-inch is in 100-foot sections, but 2.5 down, your attack hose is in 50-foot sections. So you just can't count the sections. You got to figure in how many lengths of hose that you have, so you can come up with 100 foot. So that confuses a lot of people when they're trying to do this. When you're trying to guess what size hose to use and what you're doing, you need to know some general ideas about what you're flowing for water and what each line will do. And if we go to a typical fire here in Scarborough, you're going to have usually three hose lines off an engine, and they're all going to be 1 3/4. So each one flowing will move 555 gallons of water. That's what your capability is with 3-inch and 3/4 lines, is you can move 555 gallons of water. One of the reasons you need to know that is because you need to know how close you're getting to the capacity of your pump. We got 1,500 gallon minute pumps. You need to know that, okay, I'm not anywhere near that yet. But do you have enough water supply to be able to maintain 555 gallons? Another thing that happens a lot in Scarborough, or typically a lot of places, is you'll get a couple of 1 3/4 going and 1 2.5. So when you add up the gallons per minute from the 2.5, from the 2 3/4, that's 370. A 2.5 does 250. Now you're up to 620 gallons a minute. So you're pumping 600 gallons a minute. Still within the capacity of the truck, still, but you need to be able to figure out, do I have the water to be able to do that? Another thing that happens a lot, you'll do a couple of 1 3/4 lines, you'll do a deck gun, for maybe a blitz attack, knot something down, and then be able to go pump, be able to hit it, not finish it up later with a couple of 1 3/4. You're still only at, when you add that together, the 370 and a 500 gallon minute deck gun, because that's what everything's set up to flow initially, except for the ladder pipes. But the deck guns on top of the trucks are set up for 500. That's only 870 gallons a minute. So you're still within the capacity. You're now at the half. In fact, you're over half the capacity of the truck. So that's just, it'll definitely do it, but the truck's going to be working. And you need to know, again, are you going to be able to maintain that supply? I went over this at the hands-on section again last week. I add into water supply and pumping classes time of flow. No one talks about this. It's because most of every operation, I don't care where it is, you initially start out, you could be in Union, Maine or New York City, you start every operation off tank water and then change over to your water supply. So that means in Scarborough, we have 1,000 gallons a minute. Now we have 1,000 gallon tanks. One hose line, 1 3/4 flowing, steady. You've got 5 minutes of flow because you got 185 gallons a minute coming out. So just think about that time factor, that it's not water conservation. You use the water that you need, but to put the fire out or knock it down and reset the fire. But you have 5 minutes of water left. You have 5 minutes total flow. So if you just open the bail and you're going to be bailing water, you've got 5 minutes. Again, if you just add one more line and go to 370, you're down to 2 minutes. So if you've got a crew that's going in and a crew that's outside doing some outside work, you have 2 minutes of flow, of available water, of available steady flow to be able to do what you got to do before your guys run out of water on the inside. And that's what I really more worry about, is that people going in need to understand that you've got that amount of time of flow left. That's why pump operators, that's why we practice getting water supplies hooked up so quickly in that 4 minute mark. That's why we try to aim for that 4 minutes to get water supply established, and so that you can overcome this. So you don't have to rely just on the tank. This is what I'm looking at right now. This is the one that's online for under the Scarborough. It's in the Scarborough SOPs. It's somewhere in there. It's one of the documents. This is the flow chart that should be on the pump operator's chart, should be on each pump panel. If that's not on there, let us know today and we'll get you one so we can put it on the pump panel. But everything that you look on this is what you need. Tell you is 1 3/4 is 185 gallons a minute with a 15/16 tip. You need to pump at 53 PSI, call it 50, per 100 feet of hose. And you know it's got a smoothbore nozzle because it says, and then you look right here at the top, it says smoothbore nozzle, 50 PSI. I know I'm going to pump 185 gallons a minute. So I've got 200 feet of hose. So there's 50, there's 50, and there's 50. That's how you come up with pumping the hose lines in the speed lays at 150 gallons a minute. There's an aversion in the fire service to do these things. It's one of the reasons the fire service has always traditionally made this very complicated, and I've never understood why. To take it from the aviation world, whether it's the military or the civilian aviation world, they have checklists, they have charts. So much of the math stuff that works with aviation is all on charts just like this, so that pilots and co-pilots and flight engineers and boom operators and crew chiefs can all just, okay, we need to do something quickly, pull up that chart, I got this setting, I got this setting, this is what we need. That's why these work really well for the fire service, so that when you, at 2 o'clock in the morning, are trying to set up a hose line to go inside, set up an attack line to go, an exterior exposure line, and then set up a deck gun, you're able to quickly and easily just look at these pump charts and come up with the right pressures to pump to get the right flows. It's easy to use. It always works. All you need is a light, and sometimes if you don't have a flashlight, there's a headlight on the truck. So look at that. Everything you need to know is on here. You got the friction loss for 5-inch supply right over here for each gallon per minute, from 400 gallons a minute down to 18. The discharge pressures that you need for fog null, everything. Everything is on here, okay? That's why these charts are very invaluable, just really invaluable.
You can email that out to everyone later on this afternoon.
Yep. So, all right. I know I threw a lot of numbers at you, and I threw them at you really fast. Questions? You have to unmute yourself to ask a question. No questions. Okay. So here's the deal, is that I know that for the people that, and this is for the people who are going to be doing the state class, we're going to go over this stuff again in one of the classroom sessions we got coming up. I'm going to go over this stuff again, and then we're going to go out and actually apply it. That's going to be for one of the evening sessions. That's the evening sessions that come up. It's listed as a classroom / hands-on. That's what we're going to do, is we're going to practice using this chart for the state test. We're going to go over the Q stuff. We'll go over the stuff that was in the slide so that you guys can be set for the quiz. But I'm really more concerned in the practice sessions is being able to use this chart to be able to generate the right pressures and how to do that. If you have any questions on this stuff, if you got anyone that you need to ask about, you can come to me. There's some really good people. Lieutenant Bennett, another really good person on being able to explain this stuff. Mark Stoltz, Captain Stoltz is another good one. The deputies are a good resource. There's a lot of people around that really have good knowledge. The one sitting behind Shelby, Mr. James Bradley, knows this stuff pretty well too. Smile once in a while, James. Let us know that you're alive. Thank you. Take a breath. So, but thanks for joining. Like again, if you have any questions, just ask, stuff like that. I know it's a lot of numbers and I know it's a lot of stuff, but learning how to use this chart right here is invaluable and solves so many problems when it comes to working on the fire ground and being able to pump a truck appropriately. All right, so that's it for today. Thanks a lot, and we'll talk to you guys later.